Let's take a look at this example. We're supposed to find the following currents, and we're supposed to find the voltages and powers. So let's take a look what's happened over here. Okay, so of course current is going to go from the positive terminal to the ground because we use conventional current flow. So the current I1 is going to go in this way. I2 will go this way, right? This is going to be my I2. This is going to be my I3, right? I3. Please notice that resistor R3 is shorted, okay? It's short. So means current is not going to bother to go by this resistor. So my I3 is equal 0 amps, okay? Because it's shorted, okay? And my I4 is going to go this way. My I8 is going to go this way. My current I6 and I7 is going to be equal 0. Okay, this current I6, 7, right? I can say this is equal I6 and this is also equal to I7 is equal 0 amps. Why? Because this circuit is shorted, okay? These two resistors are shorted, so current is going to go by resistor R5 and is going to go straight to the ground, right? I mean, by the resistor R8 will go to the ground. It's not going to bother to go over here because this is resistance, which is short. Okay, so my I5 is going to go this way. Okay, so we found the directions of the currents. So next we're supposed to find the following. We're supposed to find these currents, but we said that I7 is equal 0 amps already, so we found I7, right? And this is basically it at this moment. And we found also I3. We found I3 is equal 0. So next we're supposed to find I5. So in order to do so, let me redraw the circuit a little bit. So I have voltage source, and I have resistor R1, I have resistor R2, I have resistor R8. My resistor R3 is short, okay, so I don't consider it. And this is my resistor R4, and I have resistor R5 over here. So this is my circuit, how it look like. This is R5. Okay, so as you can see, resistor R2, R4, and R5, right? They're in parallel, right? They're in parallel. So what I'm going to do, I'm going to simply find the equivalent resistance for these three resistors. So R2, 4, 5 is equal 1 over R2 plus 1 over R4 plus 1 over R5. And this is equal R2, 4, 5 is equal 1 divided by R2, which is equal 5K, plus 1 divided by R4, which is also equal 5K, plus 1 divided by over R5, which is equal 3K. Okay, so this is equal R2, 4, 5 is equal 1 divided by open parenthesis 1 divided by 5 exponent 3 plus 1 divided by 5 exponent 3 plus 1 divided by 3 exponent 3 close parenthesis. This is equal 1.36 kilo ohms. This is 1.36 kilo ohms. Next, I supposed to redraw the circuit, and I'm going to have voltage source, and I have my R1. I'm going to have over here my R2, 4, 5, and I have R8. Okay, so now you can see that all these three resistors are in series, so you can find total resistance. Let me write this down over here. So R total is equal R1 plus R2, 4, 5. Okay, 2, 4, 5 plus R8. So R total is equal R1 is equal 1 kilo ohm plus R245 is equal 1.36 kilo ohms plus R8, which is equal 3 kilo ohms. So this is equal 5.36 kilo ohms. This is my total resistance. Now I can find I total. I total is equal voltage source over R total, where voltage source is equal 9 volts over 5.36 kilo ohms. This is equal 9 divided by 5.36 exponent 3. This is equal 1.67 milliamps. Okay, so this is the total current. The problem is asking me to find P1, right? You have to realize that I total is equal to the current which goes through resistor R1, okay? So I can say that my P1 is equal I total to the second power times R1. I total is equal 1.67 milliamps raised to the second power times R1, which is equal 1 kilo ohm. And this is equal 1.67 exponent 3 negative to the second power times 1 exponent 3. This is equal 2.78 milliwatts. Okay, so this is my P1. We found P1. Next, we're supposed to find V2. We can find V2. Supposed to realize that V2 is equal voltage across resistor 2, 4, 5. So now I'm supposed to say that this is equal I total times R2, 4, 5. I total is equal 1.67 milliamps times R245. R245, we found this is equal 1.36 kilo ohms, and this is equal, so now we're supposed to multiply 1.67 exponent 3 negative times 1.36 exponent 3, and this is equal 2.27 volts. Okay, so this is my voltage at resistor 2. So we found V2. Next, we're supposed to look at V6. We said that the current through the resistor R6 is equal 0. So if there is no current, there is also no voltage. So we can say that V6 is equal 0 volts. So next, we can find I5. I5 is equal V5 over R5. V5 is equal to V2 because these resistors are in parallel. So we found that V2 is equal 2.27 volts over R5, which is equal 3 kilo ohms. So I5 is equal 2.27 divided by 3 exponent 3. This is equal 756. This is 756.67 microamps. Okay, so this is my current I5. Next, I supposed to find P4. Okay, please notice that voltage across resistor R4 is also equal to the voltage across resistor R2. So I can say that this is V4 to the second power over R4. This is going to give me power 4. So V2, okay, which is equal also my V4, this is 2.27 volts to the second power over R4, which is equal 5 kilo ohms. This is equal 2.27 to the second power divided by 5 exponent 3. This is equal 1.03 milliamps. 1.03 milliwatts, I supposed to say, milliwatts. Okay, so P4 is equal 1.03 milliwatts. Next, I supposed to find P total. P total is equal I total times voltage source. I total is equal 1.67 milliamps times the voltage source, which is equal 9 volts. This is equal 1.67 exponent 3 negative times 9. This is equal 15.03 milliwatts. Okay, so this is the total power in my circuit. So we found I3, we found I5, we found V2, V6, we found P1, P4, and P total, right? So we can say that the problem is solved.